In this video, we present SuRE, an interactive visualization tool that helps you explore and understand black box models. So SuRE is based on a rule generation algorithm that tries to produce high-fidelity if-then rules to describe the behaviors of a black box classification model, even without having access to the internal of the model. We call these rules surrogate rules because they are not used for prediction, but to approximate and describe the original model's prediction behaviors. And during the process of rule exploration, you will be able to learn how the model makes decisions for different groups of instances. And then you can gain a global understanding of how the model makes decisions in general and where it performs well or poorly. Now the system in front of you is the user interface of SuRE with the least number of rules that cover the behaviors of your model. This interface consists of three parts: settings and legend on the top, a rule table, and a graph. Now let's focus on the rule table and have a look at the rules that are generated to describe a model which predicts whether a loan applicant will default in the future based on his or her credit records. In this case, red represents the positive clause of default, and blue is for the negative clause of not default. Here, each row is a rule, and the rectangle in a cell shows the condition of the rule combined with the corresponding column. For example, here this cell shows a range with median and low values of bills paid on time. More specifically, as indicated at the bottom of the table, it means bills paid on time smaller than 95%. Similarly, this means average months in file smaller than 102, a range of relatively median and low values. And for most of the instances that match the two conditions of bills paid on time smaller than 95% and average months in file smaller than 102, they are more likely to be predicted as default by the original model. For those instances that match a rule, we use a few visual components on the left side of the table to describe the model's prediction on them. The first is a percentage of predictions made by the original model. Then it follows a few bars showing whether the predictions are correct or not. More specifically, they represent true positive, false positive, true negative, and false negative. For example, the red rectangle with shadow represents the percentage of instances which are predicted as default, but are actually not default. And then this bar shows the support of a rule, or the number of instances that match the rule. We'll also have the fidelity of a rule in the end. In this system, we can sort the rules by predictions to check how the model differentiates the clause of default and the clause of not default. And now we can see that for the subgroups with a prediction of default, most of the applicants do not have a high value for bills paid on time and usually have a relatively high unpaid balance. And to check where the original model performs well and where it makes mistakes, we can sort rules by true positive, false positive, true negative, and false negative. Moreover, we can sort rules by support to check how the original model makes predictions on most of the instances. And if you want to focus on a specific feature and explore its relationship with the predictions, we can sort rules by conditions. Here we can roughly see that low values of unpaid balance are more relevant to not default, while instances with a high unpaid balance are more likely to be predicted as default. Actually, one instance can match one or more rules in the rule set, and for those subgroups of instances that match a specific rule, we have a graph on the right-hand side of the table to demonstrate the intersections between different subgroups. Here, each node represents a subgroup, and the more instances in a subgroup, the larger the corresponding node is. Similarly, the width of the link in the graph represents the intersection of the connected subgroups. And the more similar the two subgroups are, the closer the two corresponding nodes are. In the process of exploring the rules, you may want to explore more detailed and higher fidelity rules. So you can change the settings by clicking the gear on the top. In the setting menu, you are able to change 4 parameters: minimal support of each rule, minimum fidelity of each rule, and the maximum number of features used in one rule, as well as the number of value bins we can set for each feature. For example, you can increase the minimum fidelity of the rules to 95%. And because you want to have more detailed rules, you can set the most number of features at 3. Now you have more detailed rules as descriptions, and you can further explore the rules and semantically validate and understand the original model's behaviors by interacting with these rules.